Bismillahirrahmanirrahim. Assalamu alaikum, students. I hope all of you are good and doing well at home. So, students, as you know, that we have started our chapter number sets, chapter number one, sets, and this chapter belongs to your arithmetic section. And I welcome you all again in my class. Students, as you know, your midterms are going to be started from first Feb, so you have to prepare your midterms from the given syllabus. Okay, and the topics that we have done in final term, these topics are not included in final term. Okay, you just have to prepare those topics. Okay, so you just have to prepare those topics that are coming in midterms only. Okay, now let's start the lecture. So in today's lecture, what we are going to do, we are going to learn some basic concepts of regarding sets. First, we will learn what does it mean by one-to-one correspondence. Okay, what does it mean? One-to-one correspondence. Okay, one-to-one correspondence is our first topic. The next topic is equivalent sets. Okay, the second topic is equivalent sets. Third one is disjoint sets, and the last one is overlapping sets. Okay, so these are the topics that we are going to cover today, and after this explanation, we will do classwork. Okay, you will copy down the definitions. I will explain. I will dictate all those definitions. Understand? So let's start from definition number one, which is one to one correspondence. Now, what does it mean by one to one correspondence? Look at this figure. Okay, in this circle, what you have, this is a circle A, or you can say set A, in which the elements are A, B, and C. Okay, this is a circle in which circle name A, set A. Just suppose this is a point of set A, and in which you have elements A, B, and C. Another circle is circle B. Okay, in which, no, do not do this work in copy. Okay, in which you have the elements which are 1, 2, and 3. So as you can see, A and B are the set here, and this set A has element A, B, and C, and this set B has elements 1, 2, and 3. Okay, if I tell me whether the elements are same or different. Elements are same or different. Hmm? Elements are same or different. Different elements. Okay, so if the elements are different, so you will not say that the given set is equal set. So okay, but as you can see here, the number of elements are equal. Number of elements are equal. Just suppose here you have this one, then this one, and this one. So here you have the number of elements equal, means you can establish a one to one. Okay, one to one correspondence means equal. Okay, so what is a correspond one to one correspondence? Two sets. How many sets are there? Now look at here, just a minute, just give me a minute. Yes, now look at here, two sets. How many sets? You have two sets. Okay, now which two sets are here? This is set A and this is set B. Okay, if you have two sets, so they are set to be in one to one correspondence. One to one correspondence, or simply you will write one to one correspondence if to each element of A, means each element of A, there corresponds one and only one element of B, and vice versa. Means if you have a corresponds of one element to another element, so you will say that these sets are one to one correspondence. Just suppose if I'm going to make the set here, just suppose this is your set A, which is equals to, this is set A, which is equals to 4, 5, okay, 6, and 7. Okay, and this is the set B element. Now the what are the set B elements? Just suppose set B elements are A, B, and C. Okay, and then close. Now if I'm going to establish one to one correspondence, so we will establish the one to one correspondence between these two elements, then we can establish the one to one correspondence between these two elements, And then we have the element 6. 6 will be corresponding to 7 C. Now what about 7? Where is the correspond of 7? No correspond of 7. Okay, so we will say that A and B are not corresponding to each other, means we cannot establish one to one correspondence between A and B. So for one to one correspondence, what you have, the number of elements in both sets should be equal. If number of elements, I'm talking about only the number, not the type of element. Okay, I'm talking about only the number of elements, not the type of element. So you will say that you can establish a one to one correspondence between two sets. Okay. Next is equivalent sets. Now there is a difference between equality of sets that we have done yesterday and equivalent sets. Now what are equivalent sets? Two sets. How many sets are there? Again, you have two sets which are in one to one correspondence, means you can establish a one to one correspondence. So those sets, if you can establish a one to one correspondence between two sets, so those sets are called equivalent sets. Keep it in your mind. In equivalent sets, your number of elements, your type of elements should be different, it may be different, okay, but in equality of the sets, type of the elements and number of elements should be equal. So now let's consider this one. If you have a set M whose elements are 1, 3, and 5, okay, M is equals to 1, 3, and 5, and N is equals to 2, 4, and 6. So as you can see, elements are different. So you will say that these sets are not equal. But here I am talking about equivalent sets. Okay, equivalent. So when you will say that the sets are equivalent, when you will establish the one to one correspondence. Now look at here, how will you establish one to one? This one, this one, and this one. So you can establish a one to one correspondence. So you will say that then set M and set N are equivalent sets. Why they are equivalent sets? Because one to one correspondence can be established between them. Okay, although the elements are different. Here you have 1, 3, 5, and here you have 2, 4, 6. Okay, elements are different, but still this set is called equivalent sets. Why? You can establish a one to one correspondence. Okay, if you have element set A element which is A, B, and C. And another set is set B, which has elements A, B, and C. So what these sets are? Basically, you will say that A is equals to B. Okay, A is equals to B. For equality of sets, type of the elements should be equal. Number and type of the elements should be equal. Correspondence for correspondence, what you have to establish a one to one ratio. If you will establish a one to one ratio, so you will say that this is corresponding, this thing in which you will establish one to one ratio, this thing is called correspondence. Okay, so one to one ratio is established, so you will say that they are one to one correspondence to each other. Understand? Now move on to the next one. Next is disjoint sets. Now what are disjoint sets? Look at here. Disjoint. Okay, I'm repeating again, disjoints. Two sets are called. How many sets are there? Two sets are called disjoint. Disjoint matlab different. Okay, disjoint sets if they have no common members. Okay, this is the opposite of equal sets. Okay, this disjoint set is the opposite of equal set. In equal set, the number and type of elements should be equal. Okay, and in disjoint sets, if none of the element is same, so you will say that the given set is disjoint set. As you can see here, this is set A which has element 1 and 3, and in set B you have element 2, 4, and 6. Okay, now they have completely different elements, huh? they have different elements, means none of the element is same or common here. So you will say that set A and B are called disjoint sets. Okay, they are called disjoint sets. Why disjoint sets? Because the elements are completely different here. If the elements are same, so you will say that the given set is equal set, and if the elements are not same, so you will say that the given set is disjoint set. Is it clear? Disjoint set is basically disjoint set is basically the opposite of equal sets, or you will say that equality of sets. Remember the definition of equality of sets that we have done yesterday? Is it clear? What are disjoint sets? If you have any two sets and those sets elements are completely different, so you will say that the sets are disjoint. Okay. Alina, I have explained what does it mean by correspondence. Correspondence means when you will establish 1-to-1 ratio. So if you will establish 1-to-1 ratio, that mean is called correspondence. Now, next is the last definition, which is overlapping set. Okay, overlapping set. Overlap means what? Look at here. Overlapping sets. Two sets. How many sets? Two sets are called overlapping. When you will say that the given sets are overlapping, if they have at least one common member. Okay, when you will say that the given set are overlapping set, if they have at least one common member and neither of the two is a subset of the other. Means what does it mean? They have some common members and they have some uncommon members as well. Just suppose consider this set. In set M, the elements are 2, 4 and 6. Okay, 2, 4 and 6 are the elements of set M, and elements of set N is 4 and 8. So which is the common member here? Which is the common member here? Which is the common member here? 4. Okay. And as you can see, the 2, if we talk about 2 and 6, so 2 and 6 is not present in set N. Similarly, 8 is not present in set M. Means both of them have some common members and some uncommon members. Okay, so you will see that such type of sets are called overlapping sets. Means just suppose if you have set A here. Okay, just suppose you have set A, which is equals to A, B. Okay, set A elements is A, B, and set B elements are B and C. Okay, now the same element is B. Okay, same element is B, and A and C are different elements. Okay, so you will say that such type of sets are overlapping sets. Okay, such type of sets are overlapping sets. Now please tell me, is it clear? What are overlapping sets? M and N are called overlapping sets if some members are same and some are different. Clear? Very good. Now, what is next? We have classwork. Okay, now we are going to do classwork. So all of you should open your arithmetic copy and write down the index, which is today's index 27.121 definition. Okay, these definitions are related to exercise 1.2 that we are going to start tomorrow. Okay, now write down the index. This is your today's index 27.121 definitions. Everyone kindly write down the index. Everyone, done? Okay, very good. Okay, we have started the definitions previously. So on the from the same page, okay, continue from the same page. Okay, so far we have done the definition of subset and superset here. Okay, you have done till here. Remember everyone, you must have the work arithmetic copy, math copy, in math copy. Okay, now yesterday we have done definition of subset and superset. Now we will continue from the same page. Okay, now continue after this one. The next line is about this one. Symbolically, it is written as A is the subset of B. Symbolically, it is written as A is the subset of B. No need to change that date. When you're going to start from a new page, then you will change the date, okay? Now copy down. Symbolically, it is written as A is the subset of B, full stop. A is the subset of B also means that B is a superset of A. It is symbolically written as B is the superset of A. Now copy down this definition. Now write down the heading of proper and improper subset, everyone. Now write down the heading of proper subset after that. First we will do the definition of proper subset and then write it down. If every element of set B is also an element of set A and A contains at least one element which is not an element of B, then B is called a proper subset of A. For example, I'm repeating again, if every element of set B is also an element of set A and A contains at least one element which is not an element of B, then B is called a proper subset of A. After this, write if A is equals to A, B, C, D and B is equals to A, B, C, then B is a proper subset of A. It is denoted by B is a proper subset of A. Now copy it down. I'm waiting for your reply. If A is equals to A, B, C, D and B is equals to A, B, C, then B is a proper subset of A. It is denoted by B is the proper subset of A. Now, let's start another definition. Now write down the heading of improper subset. Write down the heading of improper subset. Now write the definition of improper subset. Now this is the definition of improper subset. If every element of set B is also an element of set A and every element of set A is also an element of set B, then B is an improper subset of A. Okay. Now write if A is equals to 1, 2, 3, if A is equals to 1, 2, 3 and B is equals to 3, 1, 2, inside the curly bracket, and please make a proper curly brackets. Okay, make proper curly brackets. If a is equals to 1 2 3 and b is equals to 3 1 2, then b is an improper subset of a, and also a is an improper subset of b. Okay, then b is an improper subset of a, and also a is an improper subset of b. Next is, it is denoted by b is the improper subset of a, or you can write it down in this way: a is the improper subset of b. Okay, okay, now write down the next heading, which is equality of sets. Now write down next heading, which is equality of sets. Okay, write down next heading, which is equality of sets. Okay, now write down the definition. Two sets A and B. How many sets? Two sets A and B are said to be equal if colon, okay, if point number one, if point number one, every element of B, okay, every element of B is also an element of A, okay, every element of B is also an element of A, every element of B is also an element of A. Point number two, every element of A is also an element of B. For example, if A is equals to 2, 4, 6, if A is equals to 2, 4, 6, and B is equals to 4, 6, 2. If A is equals to 2, 4, 6 and B is equals to 4, 6, 2, then A is equals to B. If A is equals to 2, 4, 6 and B is equals to 4, 6, 2, then A is equals to B. Okay, now move on to the next definition, okay, which is one-to-one correspondence. Now write down the heading of one-to-one correspondence. One-to-one correspondence. One-to-one correspondence. Now, this is the definition of one-to-one correspondence, which is no, Miram. Okay, two sets A and B. Okay, how many sets? Two sets A and B are said to be in one-to-one correspondence, or simply one-to-one correspondence if to each element of A there corresponds one and only one element of B and vice versa. Okay, Hadika and Iman, you have to wait, or I will upload the lecture, then you will check it. Okay, students, please hurry up. Yes, you can continue from that page, Chaveria. Now, next is equivalent sets. Write down the heading of equivalent sets. Okay. The definition of equivalent sets is this one. Two sets which are in one-to-one correspondence are called equivalent sets. Two sets which are in one-to-one correspondence are called equivalent sets. For example, if M is equals to 135, N is equals to 246, then M and N are equivalent sets as one-to-one correspondence can be established between them. I am repeating again that you have to prepare your midterms exam. Okay. Okay. At the end, I would like to say thank you so much.